Okay, now don't give me these bonker eyes. Quadratic equations are not as difficult as what you think. They just look fancy, but it's really just math's way of saying, well, here's a parabola, deal with it. And luckily, we have these magic formulas, or as what I like to call it, the one you hope shows up in the formula sheet. So let's warm up with a few examples, and let's start with this one. And don't panic, this is really easier than deciding what to have for your lunch. So we have here 2 multiplied by 5m plus 3n in brackets squared. So let's expand the parts in the bracket first, and let's refer to the formula in the previous slide, which was a plus b squared. And the answer is a squared plus 2ab plus b squared. So over here, A is basically your 5m and your B is your 3n. Apologies for these drawings. So what you get is 5m squared plus 2 5m times 3n plus 3n squared. So that means 5m squared gives you 5 squared is 25, m squared is m squared. So you get 25m squared plus 2 times 5m times 3n. 2 times 5 is 10, 10 times 3 is 30, m times n is mn, so you get 30 mn. Plus 3n squared is 9n squared. 3 squared is 9, n squared is n squared. So this is just your working bit. And so 2 times 25, m squared is 50 m squared plus 2 times 30 is 60 mn plus 2 times 9 is 18. So you get 18 n squared. And that's actually it. That's there's nothing else to simplify. Therefore, this is the answer. It's a two-step with some working, so not that difficult, right? Let's go on to the next question. Let's try a similar question to what we just tried earlier. Now we factorize this completely, so which means that we need to simplify this and find similarities between 24 mn squared and 21 mn cubed. So let's expand this first. Expand and then we can simplify it. Mn squared becomes m squared n squared. And the square is specifically just for the brackets. Therefore, it doesn't apply to the 24. And over here, the cube is only for the n, so it doesn't affect 21m. So with this, what is similar? So you have 1m, you have 1m here, you have 1n here, and you have 1n here. So let's take out the m and n, and 24 and 21 also, they are both divisible by 3. So we can take out 3mn. 24 divided by 3 gives you 8. M cubed divided by m gives you m squared. N squared divided by n gives you n. 21 divided by 3 gives you 7. M divided by m is 1, so nothing to write here. N cubed divided by n gives you n squared. So that's your answer. And earlier when I said m cubed divided by m, so you have to know that, your powers, when they are divided, it's equal to minusing. And when it's multiplied, if it's multiplied, then this is 1, right? So 3 plus 1. You have to add the factors. So when you multiply, the powers get added. When you divide, the powers get minused. That is the working for this. So with that, this is your answer. Wait a minute, there's actually a mistake here. This is 2. So when I factorize it and I take out the m, the remainder should not be m squared, but instead it should be m. So, and the fact that there is a common n here, it should also be factorized. So, you know what? Let's try this again. Factorize completely 24mn squared minus 21mn cubed. So you have 24m squared n squared minus 21m n cubed, and the commonality, let's take out the commonalities here. So let's take out m, n, and n squared. And let's take out the 3 as well. So 3m n squared. That leaves me with 8m, because 24 divided by 3 gives you 8. M squared divided by m gives you m, and n squared divided by n squared gives you 1. So nothing else to write here. 21 divided by 3, 7. M divided by m is 1. N cubed divided by n squared gives me n. Now this is the right answer. Given that 1 divided by 2 to the power of a minus 1 equals to 2 cubed plus 2 cubed plus 2 cubed plus 2 cubed, find the value of a. So there's a lot of numbers, and how do we do this? So earlier I just told you that when you multiply, the powers get added, and when you divide, the powers get minused, get deducted. So let's try to do the part on the right, because that looks easier. So 1 over 2a minus 1 equals to 4 times 2 cubed, because there are 4 2 cubes, right? So it's really the same as 2 plus 2 plus 2 plus 2 plus 2 was the same as 4 times 2. So over here it's just 4 times 2 to the power of 3. And how can we simplify 4? 4 is the same as 2 to the power of 2. So over here you actually have 2 to the power of 2 times 2 to the power of 3. So you have to add the powers. So this gives me 2 to the power of 5. 2 plus 3 equals to 5, to the power of 5. And how, let's deal with the part on the left. 1 over 2a minus 1. So when something is, when I write this as 2 to the power of negative 1, this really means 1 over 2. So similarly, when I write 2 to the power of 1, how do I write this at the bottom? It's the same as 1 over 1 over 2. So the reason for this is because a over b divided by c over d is the same as a d over b c. So this is the same as 1 over 1. So 1 multiplied by 1 and 2 over 1. So this is the same as this. So how do we deal with this part over here? I need some space. So 1 over 2a divided by 2. That's what is written over here, because 2a minus 1 is the same as 2a divided by 2. So this bit goes there and this bit goes here. So this is the same as 2 divided by 2 to the power of a. So which means 2, 1 minus a. So 1 over 2 a minus 1 is the same as 2 to the power of 1 minus a. So 2 to the power of 1 minus a equals to 2 to the power of 5. Therefore, 1 minus a equals to 5. So you bring a over here and you bring 5 over here. So a equals to -4. 1 minus 5 equals to -4. So that's the answer. And if you want to check this back, you can always put the number back here and see if 1 over 2 to the power of -4 minus 1, if it's the same as 2 to the power of 5. So this will become 1 over 2 to the power of -5, which is the same as 2 to the power of 5. Okay, okay. All right, let's try to write this as a single fraction in its simplest form. 3 over 1 minus 2h squared plus 8 over 2h minus 1. Okay, so let's take a look at this. The denominators actually look really similar. 1 minus 2h, if you multiply it by -1, you actually get -1 plus 2h, which is the same as 2h minus 1. So let's use this concept to do up this question. So if you multiply -1 at the top and at the bottom, you actually get -8 over 1 minus 2h. And the negative and negative will cancel out each other and become positive. So that's what we're going to do. 3 over 1 minus 2h squared plus, then we put a negative on top and we put a negative at the bottom because now the negatives will cancel out each other and it will still mean the same thing. So what happens is I get 3 minus 1 minus 2h. Sorry, the squared is outside. Okay, I wrote it wrongly here. It's outside. Plus and minus gives me -8. Negative 2h minus 1 gives me 1 minus 2h, as I showed over here. So this is what we get. 3 over 1 minus 2h squared minus 8 over 1 minus 2h. So 1 over 1 minus 2h is common. So 3 minus 1 minus 2h minus 8. That's what I get, and you just um, make this as a common denominator, 1 minus 2h, so you have to do 1 minus 2h over here, and that will give me, let's see how I can, okay, let's remember this and write to the next slide. Minus 8 times 1 minus 2h gives me 1 over 1 minus 2h, 3 minus 8 plus minus 8 times minus 2 is plus 16h. 1 minus 2h. So 3 minus 8 is -5. So it's 1 over 1 minus 2h multiplied by 16h minus 5 over 1 minus 2h. And that's your answer. So this question. And that's how you do this. All right. So we had three questions to do, and we had a lot of marker challenges, but I hope you got the gist of it. And let me know what sort of questions you are having challenges in. And I'm more than happy to show you the worked examples of how these things work out. And remember, really, just remembering a few formulas is really enough to breeze you through difficult topics, mind-boggling topics like quadratic equations. So fret not, I'm here with you, all right? And we can navigate this together. Till then, cheers, stay safe, goodbye.